Hello everyone. Today I just talk about the set operation. Before this video, I produced for you already about the definition of set and the type of set. But today I just want to tell you something about set operation. How many set operation are there in set theory, or what is the application of set? How to solve set by diagram Venn. This is for our video, for this video which I produced for you, and the way to find or the way to solve some problem with our set operation, or solve some problem with our set by use diagram Venn. This is the goal of our lesson. So now we start to our lesson, talk about with the set operation. And set operation, there are 5 operations on set. The first, we talk about the union set. And what is union set? Union, it means that A union B equal to X, such that X is belong to A or X is belong to B. This is the definition or the meaning of our union. It means that X belong to A and X belong to B. So we take all the element of X and the element of A and the element of B each other. But we know already the element of our set just write only one time. It is not repeatedly in our set. Just write only one time. Talk about the element of our set. This is the diagram Venn of a union set A and B. We just take all the element in A and all the element in B each other. This is the meaning of set union or union set. The second, talk about the intersection set. Intersection set, it means that A intersects with B, or A and B equal to X, have X is element of A and B, such that X is belong to A and X is belong to B. Just talk only the something that is X is belong to A and X is belong to B. Just take another element that only in A and only in B each other. Other side, it is not the element of A and B. This is the meaning, the diagram Venn of our intersection set. Like this is three sets. The complement of set. A complement, this is we can call complement of A. The complement of A equal to X, that X belong to U, universal set, and X it is not belong to A. It means that when we have our example, we have our universal set like 1, 2, 3, 4, and 5. This is it. And this is A1, 2, and 5. This is only example. So the complement of A, you can write like this, is equal to the element is of U, but it is not belong to A. A is 1, 2, and 5, so not belong to A is 3 and 4. This is the complement of A. Complement of A means that X belong to U, and but X it is not belong to A. But when we got A union complement of A equal U, and A intersection with complement of A is equal to empty set. This is the some property of our complement set. And the next, this is about complement. Is for universal set, but it is not belong to A. for the different offset, it means that A different B is equal to A belong to X is belong to A and X is not belong to B. Just only X belong to A, but it is not belong to B. This one we call about the symmetric difference. It means that A different B and B different A. This is about the symmetric difference. And this is A different B. A different B, it means that they take only the element of A, it's not element of B. In here is B and A intersection. So it is only belong to A. It is belong to A, it means that just only the set is one. Over here, yeah. Like black. This is A different B. And the fifth is Cartesian product of set. This is A product B equal to X and Y. X belong to A and Y belong to B. A product with B, it is beside of B product to A. It is not equal. So this is the difference. Now this is some diagram one of our set A intersect B, A union B, like B example B or A prime. We can call about complement of A. This one we call about complement of A. And this one A different of B or A intersect with complement of B. B prime, it is equal to complement of B. B different A, it means equal to A complement intersect with B. This is A union with in complement of B. This is the kind of our diagram. This is the complement intersection of set. And this is the symmetric difference of set. This is symmetric difference of set for two. It means that for two the set A and B, or for set A, set B, and set C. This is about the symmetric difference of set. But now we go to point 1, talk about the union set. The union set, the union of two sets is a set containing all elements that are in A or in B. Possibly both, or we take about the element of A and the element of B. For example, if we have 1, 2, 3, 4 union with 2, 3, 5, and we got about 1, 2, 3, 4, 5. Thus, we can write X belong to A intersect B if and only if A belong to X belong to A or X belong to B. Not that A union B equal to B union A. In the figure below is the union of set A and B is shown by the set of area in Venn diagram. This is the kind of our union set. Similarly, there are many offsets that can be union each other. Example, we can define the union of 3 or more sets in particular if A1, A2 until AN are n set. The union A1, union A2, union until union AN is a set containing all elements that are in at least one of these sets. We can write this union more compactly by this recall about the family union. This one, the family of union. Some book they write U for I to 1 and N. AI is equal to A1 union A2 union A3 union until to union AN. This is the kind of our union, more of set that can be union each other. For example, if A1, ABC, A2, CH, A3, and AD, this is the union of, this one is A, B, C, D, and H. Intersection set. The intersection of two sets A and B denoted by A and B, or they A intersection with B, consists of elements that are both in A and B. Both in A and B. For example, if we have 1, 2, 3, 4 and have 2, 3, 5 equal to 2 and 3. The intersection of set A and B is shown by the set area using a Venn diagram. This one is the intersection of two sets A and B. So the intersection of A and B, it means that consists of elements that are both in A and B. More generally, for set A1, A2, A3 until AN is also like our this one. And now we go to point 3, talk about the complement of set. The complement of set, the complement of a set denoted by A power C or A, like this one, and it's the set of all elements that are in universal set. We use all letter S or letter U, is up to you. Sometimes they use about letter S is sample, and sometimes they use about letter U is to universal set. Are not in A. Complement of A is shown by a set area using a Venn diagram. This one is a complement. And about the different set, the different set or subtraction is defined as follow. The set A minus B consists all elements are in A but not in B, or A it belong to A but it is not belong to B. For example, if we have A 1, 2, 3 and B 3 and 5, then A different B, it means that 1, 2. We cannot take 3 because 3 is belong to A and belong to B. So if A both in the element both in A and B, we don't take to write in A different B. We just talk about only the element of A. So in the figure of A different B is shown by the set are using a Venn diagram. Not that A different B is equal to A intersection with complement of B. This is the Venn diagram of A different B. And two sets A and B are mutually exclusive or disjoint if they do not have any set element. The intersection of empty set A intersect B equal to empty set. More generally, several sets are called disjoint if they pairwise disjoint. No two of the set common element. So these three disjoint set. This is disjoint set. So A, B, C doesn't have three elements of A, B, and C. So A, B, and C is different element. It doesn't have the same element in A, B, and C. This is we can call about disjoint set. And the set operation. If the surface our sample space, we might want to partition. If the different continent similarity, a country can be partitioned if different province. So partition, it means that we can separate each other in, like our country, we separate by the province or by the town. This is the meaning of partition. So partition, it means that we have one example, we have a flat, and when you fall down the flat on the floor, it's broken out. This is the partition of our set of a flat. Like in this picture, we have the universal or the sample set, but we separate by A1, A2, A3, A4, and something. This is the partition. So partition, we can separate the universal in many pieces of our set in the sample of our universal set. Union property. This is union property and intersection property. A union A is equal to A. A intersection with A is equal to A. 2A union complement A is equal to A intersection complement A is equal to empty set or 0, or A union with empty set is equal to A intersection with empty set is equal to empty set. A union B equal to B union A intersect B equal to B intersection A. This is the kind of distribution. We can commute each other like our operation in addition, subtraction, or something. This is the kind of distribution. This is the property of subset. What is subset? If A in A intersection B, it's similar to B intersection of A union B. A in B, A is in A intersection B is equal to A. If B in A intersection B is equal to B. This is our, it means that if A subset of B, A intersection B is equal to A. If B subset of A, it means that A intersection B is equal to B. This is the kind of our subset. This is also our subset. This is the number of our element in property. Number of element in our property. The number of A intersection with U is equal to the number of A. This is the kind of our number element of our property. This is also, or we can call the cardinality. The cardinality of U is equal to the cardinality of A plus the cardinality of A complement. The cardinal of A union B is equal to A cardinal of A plus cardinal of B minus cardinal A intersection B, because A and B each join each other have both A and B have the same element. if the cardinal of A union B equal to cardinal A plus cardinal B, it means that A and B disjoint. This is of our cardinal in this is we have about A plus B, yeah. A union B and union C. We have A plus B plus N C minus this one and this one plus this one. This is have the union, the cardinal of A union B union C, and this A product with B equal to cardinal of A multiplied with the cardinal of B. This is the family of our cross product in our set. And set theory, theory of De Morgan. This is De Morgan. For any set A1, A2, and AN, we have this one is like in our logical. It means that the complement of A1 union A2 union A3 union until AN is equal to A1 plus it means that this one, yeah, union the complement A, sorry, yeah, the complement A intersect with the complement A2, intersect with the complement A3, intersect with the complement A, AN. This is the kind of our Morgan. And this is also the complement of A1 intersect A2, intersect A3, intersect until AN is equal to the complement of A1 union with the complement of A2, union with the complement of A3, union until with the complement of AN. And the distributive law, if we have about A intersect with B union C is equal to A intersect B union with A intersection with C. This is also A union with B intersect B. B intersect with C is A union B intersect with A union C. And if the universal set is given by, this is 1, 2, 3, 4, 5, 6, and A is 1, 2, B is 2, 4, 5, and C is 5, 1, 5, and 6. There are three sets finding if the following set. Find A in union B, A intersects B, A complement of A, complement of B, and check the Morgan. Does it equal or not? This is the Morgan. And check for the distributive law. So this is A union B. A union B, this one is equal to A union B. A 1, 2, 3, 1, 2, this is 2, 4, 5. So A union B is 1, 2, 4, and 5. And about the A intersection B. A intersection B. Intersection B, we take the same, both A and B, so it is only number 2. So this is equal to 2. And about the complement of A. Complement of A is belong to S or belong to U. This one we can call U or S is the same polar universal set. So A is 1, 2. Beside 1, 2 is 3, 4, 5, and 6. So this is 3, 4, 5, and 6. And the complement of B, 2, 4, 5. 2, 4, 5. So don't have is 1, 3, and 6. So this one 1, 3, and 6. This is the complement of B, complement of A intersect B, A union B. About the distribution law. Distribution law, it means that this one we have A example, we have I just draw in here. Yeah, I have this one is S or U, S or U is the same, and the next one for about A. Draw here A. Example is A and B. B and C. Something I just take this one, only A and B. A and B, B and A. B and A is 2. This one is 2. Just write 2. 2. And 1 is 1. 2 is A and C, 1. A and C, 1. Sorry, this one maybe I just draw on the hand. This one, yeah. A and C is 1. A and C is 1. So 1 I put here. And B and C is 5. B and C is 5. Is 2. This one is 4. 1, 5, and 6. This one. Yeah. This is our Venn diagram. So A intersects B. A union B is complement of A union B, and the complement of A intersect the complement of B. This is the kind of our De Morgan law. And check distributive law of defining distribution of A intersect B with B union C, and A intersect B union with A intersection C. So this is and A union B, A intersect B, A complement, B complement, and we have the complement of A union B is equal to A union B is equal to 1, 2, 4, and 5 complement. It means that we just take this one, and it's not 1, 2, 4, and 5. So it is only 3 and 6. We got 3 and 6 for number 3 and number 6. Example number 3 and 6. And the next of which is the same as intersection of complement A intersect with complement B is equal to 3 and 6. So this is equal each other. And this one is equal to 1, 2, and 2, 1, 2. And this 3% is equal to 1 and 2. This is the same about distribution law, De Morgan law, and about the complement. And this is all this example is related to our operation in our type union, intersection, the complement, De Morgan law, and distribution law. And about the Cartesian, we have the next. In the Cartesian, we have the next example. If we solve by Venn diagram, this is our example. Example 1, the first 150 college freshmen were interviewed. 85 were registered for a math class. 70 were registered for a social skill class, and 50 were registered for both math and soft skill. And the question, this is, they don't use solve about other property or something, they just want you to solve only by diagram Venn. And how many sign up only for math class? How many sign up only for soft skill class? And how many sign up for math or soft skill? And how many sign up for neither math nor soft skill? So this is only the Venn diagram solving. So you want to solve about this problem, you should be draw about the Venn diagram. The first, I want you to draw about the talk about the universal set U, like this one. And the next for about this one, and the next for this one. This is only example about mass, right? M, no, sorry. M, and this skill I write S. So we cannot worry about mass. We can write N70. We cannot N70. The first of this, we should be just write only about example. I just draw about universal set, and I draw about the set of mathematics and the set of M. This one is skill. So you cannot write for register math is 85, because 85 plus 30 plus 70 is 155, but our is only 100. So we take all intersect of mathematics and soft skill. So mathematics and soft skill is register 50. So you write only 50 in here. And about mass. Mass is 85. But this one intersect of soft skill and mass have study or register soft skill and mass have 50. So 85, so only mass is 55. And about soft skill is 70. So 70 is soft skill and mass is 50. So soft skill and mass is also soft skill. 70 plus 70 minus 50 is 20. So this one is 20. So you can count. This one is 100 and 105, but our 150. So this one is 45 for our U. This is the solving the problem by our Venn diagram. How many sign up for math class? So it is only math class. Sign up only for math class. So this is 35. The sign up only of soft skill class is 20. How many sign up for math or soft skill? Math or soft skill? Math or soft skill, it is math or soft skill. So we can take this one plus this one and plus this one. So it is 105. This is the sign up for math or soft skill. It means that they study math or soft skill or math and soft skill each other. So all the freshmen is 105. And how many sign up for neither math nor soft skill? So they don't sign up or they don't want to register with math and soft skill. It's only 45. So this is our solving some problem by our Venn diagram. And we just go to another of exercise. Example 2. 100 were student interview. 28 took algorithm. 31 took soft skill. 42 took math. 9 took algorithm and soft skill. 10 took algorithm and math. And 6 took soft skill and math. And 4 took all 3 subjects. So if you want to solve this, you should be draw the diagram like the first one. So I just draw about the universal set, this one, and I draw about the A. Example, this is only this one, and only this one. And only this one. This is only example. So if I write this one is math. This one is skill, and this one is algorithm. So the first we could not write about algorithm or soft skill or math or algorithm soft skill, algorithm math, soft skill math. We should be start from this first. 3 subject is 4. So this is 3 subject in here. We have math, soft skill and algorithm here. 4. And the next talk about soft skill and math. So soft skill and math in here also. But soft skill and math is 6. So this is soft skill and math 6. So I put only 2 because 2 plus 4 is 6. This is soft skill and math 6. But for this soft skill math, soft skill, and algorithm is 4. 4 plus 2 is 6. So 4 subject and this one math and soft skill. 4 plus 2 is 6. So we got this one is 6. And 10 algorithm and math. This one is algorithm and math. This one over here 10. But we have this one is 4. So it is 6 in here. It is 6. And 9 algorithm and soft skill. 9 algorithm and soft skill. This is soft skill, this is algorithm. 9. So this is have 4. Soft skill and algorithm is 4. And this is algorithm, soft skill and math is 4. So soft skill and algorithm is 9 is 5. So this one is 5. And the next we talk to math. Math is 42. So this one is math. Math is 12, but 42 is only math is 30. And about soft skill. Soft skill is 31. This one is soft skill. Soft skill is 11. So 31 is 20. And about algorithm 28. This one is algorithm. 4, 10, 15. 15 and 28 is 13. So this is only algorithm. So you can take all these results to complete this one. How the student took none of these 3 subjects. So that's all is 100. So this one is 50, 60, 60, this one is 50, 60, 67, 77 is 80. So this is 20. 20 student doesn't take about math, soft skill, and about algorithm. So they have only all this study about the student choose about mathematics, choose about soft skill, choose about algorithm is only 80. It's only 80. So 20 student doesn't choose math, soft skill, or algorithm. So this is 20. This is 20. And the next, how many students took algorithm but not soft skill or math? Only algorithm, but not soft skill and math. So this one it doesn't take. It is only 13. This is only 13. And how many students took soft skill and algorithm but not math? Just only soft skill and algorithm. Soft skill and algorithm but not math. Soft skill and algorithm, it means that soft skill and algorithm. So this is only 5. Because when they take 9, algorithm and soft skill is 9. But algorithm, soft skill and 9. But in 9 including soft skill, algorithm and math. But we don't take student choose math. So it is only 5. So it got only 5 student. So none took of 3 subjects is 20. Took algorithm but not soft skill or math is 15. Just only algorithm. And about the how many students took soft skill, algorithm but not math is only 5 students. This is our solving problem with our the solving problem with our Venn diagram. And the next is another example. 110 freshmen were surveyed. 25 took algorithm, 45 took soft skill, and 45 took mathematics. So the first you should be start from the last one, like our example 2. Like our example 2. So we draw about the diagram. The first we draw about the universal set, and then we draw about the like something. This one, yeah. So I just write about mass, so skill, and algorithm. So 3 took all 3, 5 took all 3. So this one 5 took all 3. So this is 5, and algorithm and soft skill 6. Algorithm and soft skill 6. So this is 1. This is algorithm and soft skill 6. And soft skill and mathematics. So skill and mathematics is 8. But we have 5, so this is 3. 5 plus 3 is 8. Algorithm and math 10. Algorithm and math 10. We have 5. So 10 is 5. So this is algorithm is 25. This one is 25 is 14 here. And so skill is 45. 45, this one is 77. Because this is 40. Oh, sorry. This is 45. 6 here. 36. This one 36. And mathematics 45. This 30. This one is 13. 13 is 32. It's 45. This one. So how many students took soft skill but not either algorithm nor mathematics? Took soft skill, but they don't take about the algorithm or mathematics. So only soft skill is 30. Is no algorithm nor mathematics. We can take this one is 36, but neither algorithm nor mathematics. Not algorithm or mathematics. So this one or non-mathematics, this one. Okay. And how many students took soft skill, algorithm or mathematics? That's all. So we can calculate this one, 32 plus 3 plus 36. 2 plus 3 plus 36, and until this one. So you can calculate all this one is I think 68, 71, 81, 82, 92, 96. This is 96. And how many subjects did not take any? How many students did not take any of 3 subjects? 36. This is 1. So it is 14. So this is 4, 14. They don't take about other thing. This is the kind of our solving by Venn diagram. Solving some problem by Venn diagram. And the next just only about the joint. It means that we have the set of can join each other. This is your problem. Application of set. A study was made of 200 students to determine what cartoon they watch. 22 students don't watch this cartoon. 73 students watch only Tiny Toon. 136 students watch Tiny Toon, and 14 students watch only American Animal, and Pinky, the Brain, and 31 students watch only Tiny Toon and Pinky, but not the Brain. 63 students watch Animaniac, and 135 students do not watch Pinky and the Brain. And how many watch only Pinky, the Brain? This is your problem. I want you to solve this problem for me. This is you can use by a Venn diagram to help you to solve about how many watch only Pinky, only Pinky and the Brain. This is your work for me. So now I finish our video or my present here, and we will start to I will start to to produce another video for you about application in our set in real life. Thank you very much for your watching this video. See you in next video. Bye bye.